Hello everyone, welcome to class. This is the second section that we're about to cover, section 1.2, graphs of equations in two variables and covering circles also. The first thing that we're going to do today is we're going to talk about determining if a point is a solution to a equation. So in our first example that we have here, we have this equation 2x minus y is equal to 3, and for our first point at 2, 3, we're going to go ahead and see if this is a solution. So what we're going to go ahead and do is substitute, and when we substitute, we're going to plug in the 2 for the x and the 3 for the y, and we're going to check to see if that's equal to 6. Well, 2 times 2 is 4 minus 3. Is that going to be equal to 6? Well, 4 minus 3 is 1. And we can see that that is not equal to 6, so this is not a solution. Likewise, in our second example, we're going to substitute into that same equation, and we're going to go 2 times 2 minus a negative 2, because we have a negative 2 for our y, and we're going to check to see if that's equal to 6. Well, 2 times 2 is 4, and negative in a subtraction sign will become a plus 2. And we're going to see if that equals 6. 4 plus 2 is 6. And we see that they are equal. So this is a solution to this problem that we have. Now another example that I want to show you today that could be beneficial for you with the homework is graphing by plotting points. So I decided to use this equation y is equal to x squared minus 1. And I'm going to use the points negative 2, negative 1, 0, 1, and 2. I'm going to show you the work for each one of these so you can see. So to find what my y is for that negative 2 point, I'm going to substitute for x that negative 2 and square it, and then subtract the 1. So that's going to give me 4 minus 1, and so I'm going to have a result of 3. So at negative 2, when x is negative 2, my y will be 3. Likewise, I'm going to try that for the rest of these x values that I had, and you're going to see that we get a variety of values. So in this one, the negative 1 squared became a 1. Subtracting the 1 from it, we got 0, and so we get 0 there. Y is then equal to 0 squared minus 1, and that's going to be 0 minus 1, which is going to give us a negative 1, and so we get a negative 1 for the 0. Now on the positive side, we're going to go 1 squared minus 1. That's going to be 1 minus 1, which gives us a 0. And we can see that the 1 and the negative 1 both gave us 0. We'll talk about that in a little bit more detail later on in the class, or later on in this, maybe in this section. Then the last problem is going to be 2 squared minus 1. That's going to give me 4 minus 1, which is 3. And now we have our points. So let's go ahead and graph that so we can see what this result is going to be. So if I call this the x-axis, and this right here is going to be the y-axis, again, we know the origin is where the x and the y-axis cross, so let's go ahead and plot our points. So negative 2, 3 is going to be right here. Negative 1, and this is the origin, just so you guys can see that's the origin. Negative 1, 0. Is right here. 0, negative 1 is this point, 1, 0, and then 2, 3. Now when we graph this thing, we can see it's going to look like this, and we see it's a parabola. Now, something about this that I wanted to point out to you is that this point and this point here are called the x-intercepts, and this point right here is the y-intercept, and it's also known as the vertex when you're talking about a parabola, but that's something I'm sure you already know. But if not, it's always good to be reminded. All right. Using that same example, we're going to actually find this algebraically. So to finding the intercepts of an equation, so y is equal to x squared minus 1, to find the x-intercept, we're going to set y equal to 0. So that means in our equation we're going to get 0 is equal to x squared minus 1. So 0 is equal to, that's a difference of squares, and so we can factor that to get this. So we're going to set each one of those equal to 0. And we can see x here will be equal to 1, and x here will be equal to negative 1. Let me make that a little bit neater for you. That will be a negative 1. And we can see that these two are the x-intercepts. Likewise, to find the y-intercept, we're going to set x equal to 0. So there's the distinction between the two. This one we set y equals 0 to, and for the y-intercept we set x equal to 0. So to do this, we're going to go y is equal to, now we're substituting the x is 0, so we're going to get 0 squared minus 1. So we see that the y-intercept is negative 1. And that should confirm with what we have here, right? We see this is the x-intercepts, and this one was the y-intercept. But we confirmed it mathematically here. Okay. I want to give you a couple definitions that could be beneficial for you in the class, and here it is. A graph is said to be symmetric with respect to the x-axis if for every point xy on the graph, the point x negative y is also on the graph. So let me just give you a quick example of that so you guys can see it pictorially. So here again is the x-axis, here's the y-axis, and so I'm going to plot some points. So I'm going to plot this here for you, and we're going to see it's a parabola that looks sideways, right? And this point right here we see is 4, 2, and this point right here is 4, negative 2. So we can see this is symmetric about the x-axis because we have the same x-coordinate, but our y-coordinates are different only in sign. This is to be symmetric about the x-axis. Similarly to this, we have a definition for the being symmetric about the, this should not be the origin. This should actually be the y-axis here. So let me fix that. That should be the y-axis. And the rest of the definition is correct. It's for every point the x, y on the graph, there's a point negative x, y that is also on that graph. So again, here's the x-axis, here is the y-axis, and so we're going to get, this is the origin here, we're going to plot a point here, we're going to go to 2, 4 here, and 2, 4 here, and we're going to have a parabola that opens upwards. And so we can see that this point here is 2, 4, and this point over here is negative 2, 4. Again, now this thing is symmetric about the y-axis. Basically, we could fold it and we see that they would fall on top of each other. And again, it's the x's in this case that change sign, not the y's. Now, for the origin, and this one here is symmetric about the origin, we're going to see that there's a change for the value of the x and y to be negative x and negative y. And again, let me show you a picture of that. So here's the x-axis. Here again is the y-axis. And so, let's see. Here's this curve. This point is 2, 8. This is negative 2, negative 8. And we can see it's precisely doing what the definition says. It's x, y here. It's negative x and negative y there. This is symmetric about the origin. And this is what the definition says to do. Now let me show you how to do this algebraically, just so you can check to see if we have symmetry. So here's an example. So if I give you this problem, y is equal to this quotient 4x squared over x squared plus 1, what we're going to do to check for symmetry about the x-axis, we're going to replace the y with the negative y. So I'm going to get negative y is equal to 4x squared over x squared plus 1. That results into y is equal to a negative 4x squared over x squared plus 1. Now, the important thing here is it should be equal to the original problem. Is this equal? It is not. And since it's not, this is not symmetric to the x-axis, or about the x-axis, some would say. Let's check that same problem for the y-axis, and so here I'll write the problem again just so we have it. And we're going to switch, we see the x with a negative x, and so to do that, this implies we're going to get y is equal to 4 times a negative x, that's being squared, over a negative x squared plus 1. Well, 4, if negative x is squared, a negative becomes a positive when it's squared, so we're going to get 4x squared. And on the bottom, the same thing is going to happen. We're going to get x squared plus 1. We notice that this is equal, and therefore, 3 dots mean therefore, this is symmetric about the y-axis. Alright, so now let's check it about the origin. And we see that about the origin, what we're going to change is both the x and the y. So again, let me write the problem so we have it. It's going to be 4x squared over x squared plus 1. And now changing that, we're going to get negative y is equal to 4 times the negative x, that quantity squared, negative x squared plus 1, and we see we're going to get negative y is equal to 4x squared over x squared plus 1. If we clean that up, we're going to get y is equal to a negative 4x squared over x squared plus 1. Is that equal? No, so therefore this is not symmetric about the origin. Alright. Now we're going to talk about circles a little bit. And so when we write a circle in standard form, first of all, I want to give you a definition, and that definition is that a circle is a set of points in the xy plane that are fixed distance r from a fixed point hk. The fixed distance r is called the radius, and the fixed point hk is called the center of the circle. So hk is the center, while the r is our radius. The standard form for this equation then is going to be x minus h, that quantity squared, plus y minus k, that quantity squared, is equal to the radius squared. Now, something important about this, when in parentheses in this case, that's actually a positive h and that's a positive k. Had they been a negative number, that would have been x plus some number. Had the k been some negative number, that would be y plus some number. Okay. The standard form of an equation of a circle of radius r with center at the origin 0, 0 is, and this should make sense. We're going to go, they're giving us an h, that h is 0, and they're giving us a y, or they're giving us a k, which is 0, with the radius still squared. So x minus 0 is simply going to be x squared plus y minus 0 is simply going to be y squared. So if we have a circle at the origin, the equation that we have there is x squared plus y squared is equal to r squared. Let me just highlight that equation there for the standard form of the equation. Now, there's a special circle that we're going to be using quite a bit in this class, and that's going to be a circle with a radius of 0. And that is going to be called the unit circle. We'll be delving into that quite a bit in this class. But the equation for that is going to be x squared plus y squared, and if the radius is 1, it's going to be 1 squared, which is 1. This is a very, very important circle for trigonometry, and we'll be using it quite a bit. Okay, let's move on to an example so I can show you how to actually do this. So in this example, it says, write the standard form of an equation of a circle with a radius of 5 and a center at negative 3, 6. So if we remember what the equation was, it was x minus h squared plus y minus k squared is equal to r squared. Now, this is something that I try to do always. When I do problems, I write the formulas that I know that are used for the problem so that they become embedded in my brain and I remember them. So we know that our h is negative 3, so that's going to give me x minus negative 3, that quantity squared, plus y minus 6, which is the y, that squared, is going to be equal to 5 squared. So then that's going to give me x plus 3 squared plus y minus 6 squared is equal to 25. This is the standard form of this equation for this radius and point. Okay? Alright, well, let's see how to graph this. So to graph this, looking at this problem, what do we know that the center is? What is our h? What is our k? Well, since this is a plus 3, that implies that it's a negative 3 for the x, and then the 1 with the y here is positive. It's exactly the opposite sign. The radius for this problem is the square root of 9. So the square root of 9 then is 3. So to graph this thing, again, here's our x-axis, here's the y-axis, and when we go to graph this thing, we're going to find a center of negative 3. So here's the origin. We're going to go negative 3, and we're going to go up 1. So that is our center. Now the radius is 3 away, so I'm going to have a point here. We're going to have a point here, right? A point here and a point here. Now, the reason that we have those points is because this distance is 3. This distance is 3. This distance is 3, and this distance is 3 because that's our radius. Now we have to connect these outer dots. Bear with me, I'm not the greatest artist. And so we see that the red was the radius. This center point here is negative 3, 1. And that's how we graph this problem. So you find your center, and then from the center you're going to count out 1, 2, 3 in straight lines. 1, 2, 3, 1, 2, 3, and then 1, 2, 3. And then just make a curve around it as best you can. Okay. Another form for circles that we're going to use is the general form of an equation of a circle, and that is x squared plus y squared plus ax plus bx plus c is equal to 0. Now, this is where I'm going to give you problems where you're going to really have to put in some effort. But we'll be able to do it. It's going to bring back some of the algebra that you might be a little bit rusty on, but yeah, again, if you need help with that, please by all means ask, and I'm more than willing to help. So in the example that we have, the first thing that I'm going to do is I'm going to regroup it so that the x's are together and the y's are together. And then I'm going to put the constant on the other side. So it's going to become a negative 12. Now, in order to do this problem, we're going to do something called completing the square. And so if you guys remember what completing the square was, to complete the square, what we do is we take the number where the x term and the y term are, and we divide them by 2 and square. So I'm going to do that on the side over here. So I'm going to go 4 divided by 2 and square it. So that's going to give me 2 squared, which is 4. And so I'm going to add 4 here. But if I add 4 on this side of the equation, I have to add it on the other side to keep it balanced. Now, for the y term, I'll use a different color. I'm going to take that negative 6 and I'm going to divide it by 2, and then I'm going to square it. And so negative 6 divided by 2 is 3, and then squared is 9. So I'm going to add 9, and I'm going to add 9. Okay. So then, this now is a perfect square. It's going to end up being x plus 2 squared, and we can talk about factoring if you need me to, no problem. Just ask. And then this one here is also going to be perfect square because we completed the square. And we're going to get y minus 3 squared. And then we're going to add these 3 over here. So negative 12 plus 4 is a negative 8. Plus 9 will yield a 1. So this is our equation for this circle. And we can find easily that the center is negative 2, 3, and that the radius is 1. This is section 1.2. I hope you find this useful.